Yeah, good evening all. Online students, everyone can hear me. Yes, my voice is loud and clear. Yes. So in the last class, we are discussing about the data cleaning, where we have worked on the wrong data. If you are having any kind of wrong data, we are going to modify that data. And after that, we have worked on the wrong data type. Wrong data type means we are converting that particular data type to another data type. And if there are any duplicates, we are going to drop the duplicates. And if there are missing values, the fourth one is missing values. If there are any missing values, we are having two options, either to remove or to replace. So if you want to replace, you can replace based on the data from the data engineer team, or based on the research, or based on the statistical value. That is, statistical value is mean, median, mode. For continuous variable, we are going to apply mean or median. For discrete variable, we are going to apply the mode. So these are the things which we have discussed in the last class. Now in today's class, we are going to move on to the next one called as outliers. Now in a data set, we may have certain outliers, right? So an outlier is a data point in the data set which is distant, means which is somewhat far away from the other observations. Okay, which is completely far away or distant from other observations, which is significantly far away from the remaining data points, is called as an outlier. Now, what impacts the outliers in the data set? If there are outliers in the data set, what is the problem is? It is going to impact the statistical analysis. Some of the machine learning algorithms are very sensitive to outliers. If there are outliers, means as per the outlier, the entire value will change, means accuracy will change, everything will change. They are more sensitive to the outliers. Next, what are the reasons for outliers? What would be the reasons for outliers? Means the reasons might be data entry mistake. The reason might be measurement mistake. There might be instrumentation mistake. Okay, there might be some mistakes. So the reasons for the outlier might be anything. Sometimes data entry, measurement, and instrumentation. We are having this type of errors, right? So now, if it is a data entry mistake, if you identify as a data entry mistake, you are going to check with the data engineer team once again. Means every time we are going to coordinate with the person who has collected the data. The person who has collected the data, who is having the entire grip on the data, we are going to coordinate with them. Okay, if we are only have collected the data, or we only have done everything, we are going to check the source from where we have collected the data. In that data, whether again we'll recheck once again whether this data is a correct data or a wrong data. Everything we are going to cross verify, right? So that is data entry errors. For data entry errors, we are going to again replace that values. If someone has entered, instead of 100, they have entered 1000. So just we are going to replace. The 1000 value will be replaced with 100. We are just replacing. Now, if it is a measurement error, okay, measurement error means we are going to do the scaling, some kind of scaling. Okay, if it is an instrumentation error, then we are going to remove the values and we are going to place approximately what values would be there. So, for example, instrumentation error. What is meant by instrumentation error? I'm having a temperature sensor at Amirpet in Naresh IT building. I'm having a temperature sensor where it is going to calculate the temperature every half an hour once or every 1 hour once, assume. So morning 6 o'clock, it has calculated the temperature, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11, 12, and 1 o'clock, again, afternoon 1 o'clock, 2 o'clock, like this. Now, while it is collecting the data, one of the time in the system, it has shown me that the temperature is 60 degrees in the Hyderabad. Okay, which is not possible. In Hyderabad, which is not possible, that I know, which is not possible. So, but it has shown me today at 3 p.m. Date is today only. Today at 3 p.m. it has shown me the temperature as 60 degrees centigrade. Okay, it has shown me the temperature at 3 p.m. as 60 degrees centigrade. Now, suddenly I have seen this one. Miss, that is some mistake. There is a problem in the instrumentation. There is a problem in the instrumentation. So now how I am going to rectify this one? Okay, how I'm going to rectify this instrumentation error in this case means just I'm going to check at 2 p.m. what would be the time and at 4 p.m. what is the temperature. And based on these two, I'm going to take the average and I'm going to fill. Right? This all depends upon the situation and the project. Right? So here we have the data entry mistakes, measurement and instrumentation. And based on that, we are going to work. Now, how we are going to treat the outliers? For treating the outliers, we are having three techniques called as remove, replace and retrain. Right? Now, first option, I'm going to start with the marks. So let us take the marks. The same marks which I have considered in the descriptive statistics PPT. Okay, they also have taken the same marks with this. And first I identified the outliers. How to identify the outliers means based on the box plot. So from the box plot, you are going to identify the marks. So the marks, what is the outlier means you are having one outlier. In this particular data set, one outlier is available. All right. And which is the which record is an outlier? Just I'm going to observe that one. Q1 value is 25, Q3 is 36, IQR is 11, and any value greater than 52.5 is considered as an outlier. Any value less than 8.5 is considered as an outlier. So in the given data set, 52.5. So this is the data. Whichever the data, it is an outlier, which is having the more than 52.5. So in my data set, just I identified the outliers. How to identify the outliers means using the box plot. Now, how the box plot works means based on the IQR. So now I'm going to extract the data. Okay, this is the data. So which is having any value less than 8.5 or any value greater than 52.5 is considered as an outlier. And this is the record. Only one outlier is there. Now what I'm going to do this outlier. Now, if first option number 1, we are going to remove the outliers. How we are going to remove the outliers means simple, by using the df.drop. Directly by using the df.drop, whatever the index number is there, index number is equal to 14, and if you can write in place is equal to true. In place is equal to true means it is going to replace in the original one. If you write in terms of df1, it will create a new one as per your choice. Right? Now I'm writing like this. Now see, 59 record was deleted. Now after deleting, again I'm going to check the box plot. Now there is no value. Okay. Now in this case, I'm not having once again the outliers, because first I have got the first outlier. This is the first outlier. Okay, this outlier I have removed. Directly the record I have removed. Now since I have removed the outlier, I'm not able to find the outliers. This is option number 1. Now, for example, I will take one more data set where for the data set, it is having 2 or 3 outliers. I have removed the outliers. There also I have removed the outliers. I have used the same option, drop function, and using the drop, I have dropped the values, whichever the records are having that one. So how I can know the records means just by using this one, I'm going to extract the index numbers, and using the index numbers, I'm going to drop those particular records. Okay, done. Now, sometimes after removing the outliers, first you'll have the outliers. After removing the outliers, after removing these outliers also, still we'll get the outliers in some situations. Okay, in some situations, once again, in some situations, we are having the outliers. I will remove the already, whatever the outliers are there, every outlier I will remove. Everything, complete outliers I will remove. After removing the complete outliers, now I'll get a new data set. After removing the outliers, I'm getting a new data set. Now for this new data set, again, if I apply the box plot, now again, I'm going to get the outliers. There'll be some situation like that. How, sir? Why, sir? These two, right? How means in the first case, you have removed the outliers. Yes, you have removed the outliers. Completed, task completed. Now, after removing the outliers, for example, let us assume you are having total 50 data points are there. Assume there are 50 data points. Out of 50 data points, 2 of them are outliers. How you calculated these 2 outliers? For these 50 data points, you calculated the Q1, Q2, and IQR. Q1, Q3, and IQR values you have calculated, and based on that, you have calculated. Now, from that, you have identified 2 outliers. And now you have erased the 2 outliers. Means those 2 records you have removed. Now, total, how many data points are there? 48 data points are there. Now, for these 48 data points, you are going to reapply the box plot. Now, for box plot, now for these 48 data points, freshly it is going to calculate the Q1. How the previous Q1 will be applicable? The previous Q1 is applicable for the 50 data points. Now, this time the Q1, whatever you are going to calculate, this is applicable for 48 data points. So the Q1 value changes. Q1 changes, Q3 changes, IQR changes. It will not do in every data set. In every data set, it is not possible, but in some data sets. In some data sets, it is possible that after removing the outliers, now whatever the balance data points we are having. For example, let us assume I'm having total out of 50 data points, 6 data points are there. If I remove the 6 data points, balance 44. For this 44, again, it is going to calculate new Q1, new Q3, and new IQR. And according to that, again, the new box plot. And according to that, new outliers. Means sometimes after removing the outliers, still we'll have the outliers. This is the interview question. Okay, if you remove the outliers will be completely removed. They'll ask like this. Outliers will be completely removed. You have dropped, you have removed. Outliers are completely removed. You will feel that, you will say that, obviously, yes, sir, as we have told that we have dropped, so completely removed. No. Again, if you check the box plot for the new data, again, you may find the outliers. Because, again, the statistical values are recalculated. Is that clear? That is the reason in the real life, remove option will not select for the outliers. Reason behind that is that why you can't, they will ask you, what are the options for treating the outliers? You'll say that, sir, replace. Obviously, the answer will be replace. They'll ask immediately, hey, there is an option for remove also now. Why you are not able to remove? Then immediately you have to say that if I remove the outliers, and for the new data set, once again, the outliers will be recalculated. Is that clear? So that is the reason why we'll not go with the remove option. Next, second option is replace. Now, what is meant by replace? So based on the confirmation from the data engineer team, means who has collected the data. For example, I'm working on the some user card prediction, user car price. Okay. Now, in that year of manufacture of the car, I'm able to see that 1964 is there. 1964 is there, year of manufacture. And the cost is some 45 lakhs or 44 lakhs, something is there. Year of manufacturing is something like 1964 or 1963. Better to go with 1963. Right? A 1963 car is there and the value is some kind of 28 lakhs, something like this. How it is possible? And we are going to cross verify. And then we'll understand that instead of 2003, they have entered the 1963. 2003 or 2023. Instead of 2023, they have entered the 1963. That is some kind of data entry error. Sir, how it is possible, sir? How that type of data entry will be there? That much of difference, 60 years difference, okay. 10 years or 5 years or 2 years, 1 year means okay. 60 years difference, means someone, if you ask in the application form, if you show the date of birth and if you show the calendar symbol like this, okay, and you have to click on this calendar and inside the calendar there is a month and there is a year. Now down you'll get the calendar, and from this calendar you have to select as per your choice date, whatever the date of birth yours. Now the person has clicked on this calendar symbol, whatever the symbol is there, he has clicked, and here by default it is having 1940. Assume he will forget about this one. He will forget the year. Simply he will select the date. Miss 1940 Skara. Some people will do like that. If you open the OLX, after the class, you go and check in the OLX. In the OLX, few people will be there. They'll select the year as 1940 also. In the calendar symbol, they don't know how to drag this one. how to drag this one, and inside this, how to select the year also, some people may not know. Okay, they are using the internet, but they don't know anything, right? So in that case, we may get the wrong entries. Now what we have to do in this case? Just we are going to confirm, and based on the confirmation, we are going to replace the values. If you know the exact year, instead of 1963, it is 2023. You know the exact year. Directly, you know the option called as replace. You are going to do the df dot replace option. Okay, that is very clear. But if you are not having with respect to it is not data entry mistake. It is you have worked on that based on your research or domain expert, all these things. Okay, if data engineer team or research team or based on the domain expert, whatever it is, if you get a perfect value, replace that one. If you get a perfect number, directly if you get the number, replace with that number. That is best option. If you are not able to get the perfect number, then what is the other choice? What is the second option? Miss, the second option is statistically we are going to replace. How we are going to replace statistically means within the box plot, this is Q1, this is Q2, this is Q3. Any value less than what is outlier? Q1 minus 1.5 into IQR. Anything less than to this an outlier. Any value greater than Q3 plus 1.5 into IQR is an outlier, right? Now, what I'm going to do, this side I'm having the one outlier, which is nothing but 59. And the Q3 plus 1.5 into IQR I have calculated and I have got as 52.5. Now, what I'm going to do is just this outlier, whatever the outlier is there, this outlier I'm going to replace with the maximum value. That is 52.5 value I'm going to replace. That is statistically you are going to replace. Statistically, any value greater than this is considered as an outlier. So till this, it is not considered as an outlier. So I'm going to replace with this value. Okay, is that clear? Directly you are going to replace with this value. Statistically, you are going to replace. How you are going to do that statistically means by using the Wins-Riser technique. The technique name is called as Wins-Riser. Now, what happens in the Wins-Riser technique means Wins-Riser capping method is equal to IQR. Means it is going to calculate IQR. After calculating the IQR, tail is equal to both. Tail is equal to both means left side and right side. Both sides it is going to calculate. That is Q1 minus 1.5 into IQR, Q3 plus 1.5 into IQR. It is going to calculate on the both the sides. Once both the sides are calculated, any value less than 8.5 will be replaced. Any value less than 8.5 will be replaced with 8.5. Any value greater than 52.5 will be replaced with the 52.5. That is called as Wins-Riser technique. Now, just observe this one. Now, no module future engine. It is saying that there is no module called as future engine. Means future engine library we have to separately install. How to install that particular module means pip install future underscore engine. Just you have to install like this. Done. Now it will work. And now if you see the DF, now you can see here the last value 59 was replaced with 52.5. Okay. Is that clear? So what is the left tail cap and right tail cap means? Left tail cap is 8.5. Right tail cap is 52.5. Anything greater than 52.5 is replaced with 52.5. Any value less than 8.5 is replaced with 8.5. How these two values are calculated means Q1 minus 1.5 into IQR. Is that clear? Now, so you can select as per your choice one data set. So for example, this is the data set where see, I have done manually Q1, Q3, IQR. Lower limit, that is 8.5. These are the things I have calculated. Q1 minus 1.5 into IQR, Q3 plus 1.5 into IQR. That 8.5, 52.5. Same thing I have got here in the Wins-Riser technique also. Wins-Riser means it is going to replace the values statistically. Replacing the values statistically. Which values? Outliers. What is meant by Winsorization? The interview question. What is meant by Winsorization? What is Winsorization? Means answer. Replace the outliers. Replace the outliers statistically. Okay. Simply to say statistically replacing the outliers. Statistically replacing the outliers. If anyone asks in the interview, what is meant by miniaturization? Statistically replacing the outliers. What is meant by statistically means the upper value and lower value. Whatever the upper and lower limits are there, the upper and lower limits are calculated statistically. I have not created that values. That are calculated statistically. That is the upper limit. The upper limit is nothing but Q3 plus 1.5 into IQR, whereas lower limit is nothing but Q1 minus 1.4 in 1.5 into IQR. So just we are replacing any value more than upper limit. We are replacing with upper limit. Any value less than lower limit will be replaced with the lower limit. Is that clear? That is Winsorization technique. You are going to statistically remove. Sir, for example, I know the upper limit. Okay, based on my research, for example, I'm working some data set where in that particular future, the upper limit I know. The upper limit and lower limits, both of them I know. Okay, this maximum cannot be more than this. For example, mileage of a car is there. Okay, whether it is a petrol variant or diesel variant, any mileage of a car, what would be the maximum to maximum upper limit? 25, 26 or 30, something. I have done the research. I have checked in the Google. I have done the research. Generally, what would be the companies which give the high mileage? Out of the high mileage, as per if they are following the ARAI also means flat road. If they go on the complete highway also, the maximum to maximum they will get 27 kilometers. They can't cross more than 27. Officially, company only is not claiming more than 27. So this maximum value, I know that maximum value. How I know that maximum value? Based on the research. Based on the research, I have concluded that the upper limit of the mileage of a car can be 27. Now, if I am working on a particular car, the car company name I am having, company name, model name, everything is there. What I'm going to do? I'm going to open in the Google that particular model name, the car name, and I will check what is the company is claiming the mileage. And that value I'm going to replace. For example, this here I have seen that some Maruti Shift LXI. Okay, Maruti Shift LXI. It is giving the 64 kilometers per liter mileage, which is not possible. 64 is an outlier. I can understand that 64 is an outlier. Now I have to replace. Now how to replace? So what I'm going to do, I can't replace with the maximum value. Shift is not the maximum mileage car. It is not the maximum mileage car. I cannot replace with the maximum value. So first, before doing that Winsorization technique or something, first you have to identify this record. First you have to extract the record. After extracting that record, you have to read that record. You have to see the record. Okay, shift is there, 64 kilometers. So in the Google, I'm going to type shift LXI. I'll type like this. It will redirect to either Maruti website or to other websites where there will be some mileage of the car will be there. So the mileage will be something like 23.5 kilometers per liter. I have observed that in the website. I'm going to replace this 23.5. Got the point? So every time blindly writing the code, first load the data, blindly apply that one. Don't fix with the codes. Okay, don't do that one. So we have to check. That is the difference between an AutoML versus a real-time data scientist. In the AutoML, that will do automatically. What it will do, code in the backend, one code is there. First, it will take the outliers, detect outliers. I'm going to create one function called as detect outliers. First, it will detect the outliers. If there are outliers, apply the visualization technique. In the backend, just I'm going to apply the function, and within that, if outliers are available, treat the outliers. Yes, don't treat. I can't write the function. Treat if outliers are available, just apply the visualization technique. Blindly apply the visualization technique. We can write like this, right? But now, for example, let us assume I'm having the car mileages of the car only, different cars. I'm working on the car data set where I'm having the mileage of a car. Around 100 records are there. Now, where for one of the record is 64. Now, if you calculate the Q3 plus 1.5 into IQR, if you calculate this one, you are going to get the value as 28.9. This is the value. But your research says that it is 23.5. Now, with what value if you replace? If you replace with 23.5, you can measure the accurate answers for the future data. If you replace with this one, still you'll get the answer, but not that much of accuracy. Okay. So user car price prediction means you have to predict the car. For example, instead of the car price, instead of 4.5 lakhs, you have predicted as 4.7. 20,000 is loss only, right? 20,000 is loss, right? You're sir, 20,000 only na, 4.5 lakhs. For them, 20,000 means nothing na. For you, maybe nothing because you are working on the single car, but who are keeping with respect to 4.5 CR. Now, instead of that, if you predict the 4.7 CR, means not with one car, 100 cars. 100 cars they are purchasing, assume. Then automatically it is 20 lakhs. Loss for the company. Now, generally, company will not have with respect to 4 lakhs or 4 crores, something like this. They'll invest something kind of 4 to 100 crores. For example, in India, cars24.com is there, where we have to predict the particular car price. What is the value of cars24.com? Approximately it is 1,000 crores. For 1,000 crores investment, how we have to predict? Not a single car. 1,000 crores is not a single car, multiple cars, right? So here prediction is more accurately we have to predict, means more accurate data we have to give. If you give the correct data, if you give the correct data, you will get the correct answers. If you give the wrong data, the machine will understand wrongly and it will also predict wrongly, right? Whatever the things, sir, instead of writing 24, if I write 29, what happens, sir? Machine will learn wrongly. Okay. Machine starts learning wrongly. Automatically answers also will be wrong. Prediction also will be wrong. So that is the reason we have to give with the maximum more accurate input. For that, we have to do the research. Without doing the research, don't write blindly the code. Is that clear, guys? So for this, but each and every parameter we can't understand, medical data or any other. Exactly. For that reason, we have to take the support of domain expert. We are going to collect the domain expert. For example, in a company, within a company, if we are going to get some project related to medical, okay, first they are going to check, is there any person in our team who is capable of doing that particular project, who is having the awareness of that particular project. If there is a person, means okay. If there is no person, means immediately they'll give a job description, and anyone who are already familiar with biosciences or something in this area, added advantage, they'll mention like that. And they'll hire one data scientist along with that who is having the medical terminology experience. So he is going to play the domain expert role. What is meant by domain expert role? Means nothing but in the meetings, he will deliver whatever he knows. He will suggest to others. So whenever we are having the doubts, we'll have one meeting, whether it is online meeting means online, offline means offline. And in that offline or online meeting, he is going to suggest to others, okay, this is the terminology and this is used in this case. He will explain to others. Okay. So once he is working as a domain expert, we are going to take the support of domain expert or research or data engineer. None of them is there means then automatically statistical. Okay. First, we'll try to give the maximum accurate results, accurate input data. We'll try to give. If it is not possible, the second option is this. Is that clear? With the outliers. Now, whenever we are going to work on the data cleaning, the most important point we have to remember in our mind is research. Okay. And this will not be completed just in 1 day or half day or something like that in the company. The data cleaning and data pre-processing stage will take at least 10 to 15 days. It will take between 10 to 15 days. Okay. Project means morning they'll give the project and by evening we'll complete all the machine learning one by one, step by step. And by evening we are not going to submit the project. Okay. The entire project will be for 4 months. Exclusive data science project 4 months. Forget about the before to the data engineer, after that software development that I'm not discussing. In between, as a data scientist only, our work will be with respect to 4 months. So we are going to have with respect to 10 days, 15 days, 20 days of time for doing the data cleaning along with the data wrangling, which is a combination is called as data pre-processing. So based on the research and based on understanding levels, we have to modify the data. It is not going to be completed in just in a half an hour or 1 hour in the real life. Right? Because generally, why I'm stressing this one more clearly, because the reason behind this is many of the students in the interview, if you ask what is outlier means, they'll explain outlier means which is far away from the data set. Up to here, they'll say correct answer, perfect answer. Okay. How you are going to treat the outliers? Treat the outliers means they simply say that I'm going to replace. If you ask what is the reason behind the remove miss, they'll see at my face like this. Sorry, sir, my trainer has not told anything related to that. Okay. They'll say that the trainer has not told anything related to remove. Why we should not use the remove option or what is the reason behind that? Nothing. Simply they'll say that replace. Now, how we are going to replace means, sir, we are having from future engine import Windsriser. How this Windsriser technique works means, again, answer will be no. This is the real life. Okay. So within maximum 10 or 15 days, once we start the machine learning, I will do the mock interview. Na? In front others, we also will sit, right? You will also observe what is the answers they will give. Okay. Live mock interviews you'll see in the class. I will do the mock interviews for the students, offline students and online students. So at the time, you'll see the answers, what type of answers they'll give. Okay. They'll not give a proper answer, but they're having the full of interest. They want a very high package. Package interest will be there, but subject interest will not be there. That is the problem. You'll see in the mock interviews. During the mock interviews, if I ask any question in pandas, if I ask what is the difference between iLog versus log, they'll try to explain using the code. I don't want code. I'm asking theoretically, what is the meaning of difference? If I ask like this, let us see how many of them will answer. And if you ask that if there is a wrong data type, what we are going to do? Simply they'll say that convert. What is the reason of wrong data type? Where the mistake is there? First, we have to see that one. Now. When the interviewer has asked that if there is a wrong data type, what you are going to do? Miss, sir, first I will observe the data. And what is the mistake? First, I will rectify the data. Later, I will convert. Then I will do. Instead of that, directly they'll say that, sir, as type. We are having as type now, as type, and we'll convert. This is the answer they'll say, and generally, right? Which is a wrong answer. Is that clear? So they're not having the interest to see the research. They'll not do any right research and what is the, which record is having outliers, what is the purpose of outlier, why it is outlier, and where the mistake was done. They're not interested to identify the mistakes. They want very quick answers, very quick answers. They feel that the project has to be completed in 1 day. Instead of 4 months, they have to complete in 1 day. They'll feel like that. And at the end, they'll give the wrong answers. Right? Now, so if there are outliers, in the data set, what are the options, miss? Option number 1 is called as remove, which we generally will not select remove. The reason behind that is sometimes after removing the outliers also, still the outliers exist because the statistically it is going to recalculate once again. All the statistical parameters will be recalculated, right? And second option is called as replace, out of which replace, first we'll try with the to get the exact values. Again, we'll do some kind of research and we'll try to get the exact values, more accurate values. Not 100%, might be almost close to the original value. We'll try to get the maximum accurate original values. If it is not possible, in that case, we are going to apply the winsorization technique. Right? Now, for example, you have identified, you have done the research, and in your research, you have identified that the maximum value can be 50. This is the upper limit. None of the value can cross more than 50. Then in that case, we are going to select the arbitrary outlier capper. Arbitrary means you are selecting arbitrarily. Whatever the value you are interested, you can write here. 50 means 50, 40 means 40. Now, for example, I'm writing 40. Assume that I have written here 40. Any value greater than 40 will be replaced with 40. All the values. If I execute this one, you can see here, all the values are replaced with 40. Whatever the values more than 40 are there, everything are replaced. If I have written here 30, any value greater than 30 will be replaced with 30. All the values greater than 30 are replaced with 30. Right? So arbitrary outlier capper means any value greater than this will be replaced with this value. Minimum capping limit means any value less than this means it will replace here. Now, how this value are calculated? 30 and 6, how you have selected? Based on your research, you have selected. For example, based on the research, you have got the answers means you have to go with the arbitrary outlier capper. If you are working on the statistical miss, you have to go with the winsorizer. Is that clear, guys? When we have to apply the winsorizer, when we have to apply the outlier capper. All these applications, all these real-time applications, we are going to see in the further projects. Once we start the projects, there different data sets will be there. For different data sets, we'll have the outliers will be there and the missing values will be there. Everything will be there. And we are going to treat according to them. Right? Is that clear? So this all comes under data cleaning. Data cleaning means treating the wrong data, which is in the wrong data type, duplicates, missing values, and outliers. All this 5 comes under data cleaning. Done? Next concept is called as data wrangling. Next concept is called as data wrangling. Heading as data wrangling. Now, what is meant by data wrangling? Data wrangling is nothing but data transformation. Data wrangling means nothing but data transformation. Means here you are converting the data from one format to another format. You are converting the data from one format to another format. You are converting. You are not going to replace, or you are not going to fill, or you are not going to manipulate the data. Just you are going to convert the data. Data conversion will be done. Okay, data conversion will be done. So they are called as data wrangling techniques. What are the different data wrangling techniques we are having? The first one is called as future transformation. The first technique is called as future transformation. Within this, the second technique is called as future scaling. And the third one is called as encoding. And the fourth one is called as discretization. So data wrangling consists of 4 techniques. One is future transformation, future scaling, encoding, and discretization. Total 4. It is going to consist of total 4. One is transformation, scaling, encoding, and discretization. Now, what is meant by transformation, followed by what is scaling, and everything one by one. Let us start one by one. All right. Now, let's start with the first one called as future transformation. Now, what is meant by future transformation means any skewed data convert to normal data is called as future transformation. Converting a skewed data to normal data is called as future transformation. Converting skewed data to normal data is called as future transformation, right? So if you remember in the hypothesis testing, I told you that first we have to convert the data to normal data, then only we can apply the parametric tests. Otherwise, we can't apply the parametric tests, right? So first we have to convert. Now, how to convert? If any data is right skewed or left skewed, how to convert? If any data is right skewed, that can be converted by using the log x or nth root. Now, what is meant by nth root? Nth root means that might be square root, cube root, fourth root, fifth root, anything. Nth root. Okay, if the data is right skewed, we are going to use either log x or nth root. First, we'll try with log. Log is not giving the answer. Then we'll try with the nth root. If the data is left skewed, for left skewed distributions, we are going to apply first exponential or nth power. Okay, let us see the example. Let us see the example for this. So what I'm going to do is first I'm going to take the Stoke prediction. This is the one of the data set where we are having the related to heart stroke. Whether the person will get the heart stroke or not, we have to predict. This data set belongs to that. Where this data set is having of total 43,400 records. Okay, after the class, I'm going to upload this data set. You are going to practice, and for this data set, you are going to do the data cleaning. Entire data cleaning, entire data transformations, you have to apply for the same one data set. Okay, now this 43,400 records are there total. Now for this particular data set, now if I take the BMI, where one of them is age column and one of them is glucose column and one of them is BMI column. These are continuous variables. So the skewness will be checked only for the continuous variable, not for the discrete variable. You are not going to check for the discrete variable. Whether it is a discrete count or whether it is a normal discrete categorical also, we are not going to apply the logic for the discrete variable. Only for continuous variable, because histogram, what is meant by skewness means whether it is a symmetrical or non-symmetrical. Symmetrical distribution you have to check means you have to apply the histogram. To apply the histogram, first it should be continuous. Only for continuous data, histogram is possible. For histogram only, the bell distribution is possible. Whether the bell is symmetrical or non-symmetrical, we are going to check. So it is applied only on the continuous variable. So I'm going to take the continuous variable like BMI dot skew, which is 0.89. Age dot skew, which is minus 1.0. Sir, you told that any value between minus 1 to plus 1 is considered as normal distribution. Actually, this is also considered to be a normal distribution, basically. But assume it is a skewed. Assume it is a skewed. Basically, it is a normal. No problem. But now here, I'm having this. What is the skewness value? 0.89 plus 0.89. Now, I want to bring this skewness value to 0. If the skewness is exactly 0, it is called as perfect normal distribution. Exactly. Not even minute change. Perfect normal distribution. For perfect normal distribution, you will get more accurate results. Right? Now, so what I'm going to do, first I'm going to apply BMI. It is a right skewed or left skewed? Right skewed. Right skewed means I'm going to try with the log x or nth root. Let us try. First, I'm going to try with the log. So how to check the log means? So np dot log of data of BMI. I'm going to take the np dot log of data of BMI. And for that, I'm going to apply the skewness. Now, what is the skewness? After applying the log, now the skewness value is just minus 0.02. What happened? Original data is having some numbers. Okay, for example, what are the numbers I'm having here? 18, 19, next 39.2, 17.6, 35.9, 19.1. Like this I'm having. What I'm going to do, just I'm going to apply the log. I'm going to apply the log. So here, whatever the log transformation is there, these values are nothing but log. Okay, just if I press this one, if I execute this one, now if I check this one, it is nothing but just a log. Now, first, what is the first record? 18. Now just open the calculator. In the calculator, just apply 18 and log. Where is log? Log. Log 18 is, what is the value? 1.225. So let us check whether we have got the same value. The first one is, what is the log value? That is 2.89. So now what it is going to take means, whatever the 18 is there, 18, just give me a minute. 18. So log to the base e. Whenever you are applying the log transformation, it is going to apply to the log to the base e. By default, it is applying to the base e. Okay. Now here, what is the second value? 39.2. Now, second value, that is 39.2. For that, log to base e. What is the answer? 3.66. So I'm going to get 3.66 is the second value. So what it is going to do, for each and every value, it is going to convert to the log to base e. Now original values are 18. Your original values are 18, 36, 38.2, whatever the values are there. That is the original values. Now this is modified values, converted values. I told you, right? Data wrangling means transforming the data from one format to another format. You are doing the conversion. You are converting the data. You are converting the from one format to another format, right? So here, just I'm converting the data. Now for this new data, I'm calculating the skewness. Now the skewness value is 0.02. This is one way, applying the log. What is the second option we are having is a root. So what I'm going to try is data of BMI to the power of 1 by 2. What is to the power of 1 by 2 miss? X to the power of 1 by 2. What is the meaning of that? Square root of x. X to the power of 1 by 3. What is the meaning of that? Cube root of x. Right? So I'm going to apply the x to the power of 1 by 2. That is first square root. I'm going to apply the square root. Now what is the square root answer I have got? 0.40. The skewness value was reduced to 0.40. Now what I'm going to do? I'm going to increase the to cube root. 0.26. Yes, it is still decreasing. Next, I will try with fourth root. Next, I will try with the fifth root. Still decreasing. I will try with the sixth root. Still decreasing. I will try with the seventh root. Still decreasing. I will try with the eighth. 9. Like this, we are going to check with the value. We don't know exactly that 7th root, the number we don't know. Since we don't know exact number, that is the reason they have given the nth root. If n is fixed, every time 2 or 3 or 4 are fixed means directly they will give the answer as square root only, right? The n value is not fixed. We don't know the n value. So I'm going to try with the different values. So I'll try with the 25 something. Okay, I'll try with 25, 0.01. I'll try with 26. I'll try with 27. So almost 0.009 means almost close to 0. So by applying the 27th root, I have got this data to normal distribution. So in this way, the skewed distribution can be converted to normal distribution. Got the point? Is that clear, guys? Is that clear? So any data. So in between log and nth root, can we use every time nth root? That is, you are going to check. You are going to check both of them. You are going to check both of them. As per your choice, you can select. Which gives the normal distribution, that value we have to replace. Right? So here, just it is going to have the logarithmic transformation and a root transformation. Now, next, I'm going to try reciprocal transformation. One more, reciprocal. What is meant by reciprocal transformation means 1 by data of BMI means 1 by x. The original value is x and I'm going to convert that one to 1 by x. Each and every value I'm going to convert to 1 by x. That is called as reciprocal. Reciprocal, for this I'm going to calculate the skewness, which I have got 0.83. Now, reciprocal you have done, root you have done, and logarithmic you have done. Out of all of them, which is the best one? Which is close to almost to 0? Root. So you are going to select the root transformation. Is that clear? So here there is no best option. There is no best option. If there is a best option, nth root only always best means, then I no need to write in this one. I no need to explain also. If this is the best option, I no need to explain the second one. Directly I can say nth power or nth root. So there is no concept called as best. Okay, as per the data, it changes. In some data sets, outliers will be available. In some data sets, outliers will not be available. In some data sets, missing values will be available. In some data sets, missing values will not be available. In some data sets, skewness will be there. In some data sets, skewness also will not be there. In some data sets, the skewness value will be 0.004 only. That data set you no need to disturb. In some data set, you may have minus 4.8. The skewness value will be minus 4.8, means the data will be something like this. This much of left is skewed. For this data set left is skewed, if you go and apply exponential, it will not sufficient. Then you have to go with the nth power. For example, you are having with respect to minus 0.6 only. For that, exponential also sufficient. Right? So for which data set, which one will be applicable, that by applying the different things we are going to identify. Right? Is that clear? Next, last one is called as box-cock transformation. This is also one type of data transformation, which is called as box-cock. Just a minute, guys. Hey, can you plug it? So the next one is box-cock transformation. Now box-cock transformation, whatever the values we are having, these values will be converted to x to the power of lambda minus 1 divided by lambda. Okay, where it is going to apply the different lambda values. It is going to try the different lambda values between -5 to +5. Right? So it is going to try the different, means to be more precise. Guys, to understand the data transformation, I'm explaining it simple example. I'm trying with a simple example. X is equal to 1, 2, 3, 4, 5. This is your original data. Assume this is the original data which was in the data set. Now what you are going to apply? Log x. Log x means log to the base x. You are going to apply for each and every value log value. Log of 1, log to base e1, log to base e2, log to base e3, log to base e4, log to base e5. This is called as log transformation. Square root transformation. Square root transformation means nothing but square root of 1, square root of 2, square root of 3, square root of 4, square root of 5. For the original data, you are applying everything square root. Reciprocal transformation means 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. Reciprocal means to the power of minus 1. Simply to the power of minus 1. This is called as reciprocal transformation. Now you are going to apply the box-cock transformation. That is x to the power of lambda minus 1 divided by lambda. Now where it is going to apply first, lambda is equal to minus 5. X to the power of minus 5 divided by minus 1 divided by minus 5. First it will try with the minus 5. After that it will try with minus 4.9. After that 4.8. After that 4.7. 4.6. Like this it is going to try with everything, and it will identify for which lambda you are going to get the normal distribution, means where the skewness is equal to 0, right? So just see here from scipy.stats, I'm going to import the box-cock. Okay, and here I'm going to give in the right side, just observe first right side, box-cock of data of age, means this input column I'm giving. Okay, input data. Now it is going to apply the box-cock now, and lambda value is equal to 0.81. Okay, now if you observe this box-cock transformation, what is this box-cock transformation will do means it is going to return a data set transformed by the box-cock power transformation. After applying the box-cock transformation, whatever the data is there, it is going to return the output as the data. So if you see in the return, output, you are going to get one n-dimensional array that transformed data. Transform means after transformation, whatever the data is there, that data you are going to get, and along with the lambda value. So two values you are going to get. One is transfer data. So transfer data I'm going to store in this particular variable, and lambda value I'm storing in this particular variable. I'm going to write print lambda value is equal to whatever the value. What is this value? I'm going to print the lambda is equal to 0.81, means x to the power of 0.81 minus 1 divided by 0.81. After doing this one, it has given the normal distribution. So it is saying that it has given the normal distribution for that. After doing the normal distribution, now if you apply this particular thing, that is data of age underscore box-cock. If you apply the age underscore box-cock, you can see this is the transform data. This is the transform data. Original data, what is the original data? Data of age, column age. This is the original data, and this is the transform data. Is that clear? This is the original data. What is the original data? You can see here what is the original data you are having in the age. 3, 58, 8, 70, 14. This is the original data. What is meant by data? Data means data frame name. Data means data frame name. Instead of writing df, I have written the data frame. Data. So data of age underscore box-cock. This is the original data. This is the transform data. For this data, if you apply the skewness, this is the original data. Original data dot skew. If you check the dot skew of the original data, this is the original data skewness. Transform data. If you check the skewness of the transform data, this is the skewness of the transform data. Right? Now here, sir, the skewness has increased now. You'll ask the question, the skewness has increased. Instead of decreasing, the skewness has increased. Now, that is the reason I have told you that if within the -1 to +1, it is considered as normal distribution, we are not going to disturb that particular column. Whichever the column is having more than +1, for that only we are going to apply all these things. Okay. Now, let us apply the same logic for another data set. Here I'm having with respect to one more data set called as titanic.csv file. Okay, let me load that one. So td.read_csv. Inside that Titanic data, titanic.csv. This is one more data frame. Let me type here df. df is equal to. Okay. Now I have got the one more data set. Now for one more data set, there is a one more age column. For this column, you can see the age. Is that clear? Age column is there. So now df of age, I'm going to take only exclusively age column. This is the values. For this dot skew, I'm checking the skewness. What is the skewness? 0.38. So no need to disturb this one. Next, we'll move on to the next one. What is the next one? Fair. Fair is there. Let us try with the fair. Column fair. 4.78. Now it is a extremely right skewed data. Now what we are going to do this one? We are going to convert to the normal distribution. How to convert the normal distribution this one? One, we are going to apply either log or we are going to apply the with respect to called as root, or the third option is box cock. So here, whatever the box cock is there, just let me try the same box cock concept now. Okay, instead of giving the age, this one, I'm going to create the df of what is the input I have to give? Fair. I'm going to take fair. And whatever the new one I'm going to get, I'll write the new one, column name of the new one also I'm going to convert as fair underscore box cock, and it will be filled in the df, within the df. Okay. Now data must be positive. Fair. Where is the fair column? First data df of fair. Dot is null. I think they are missing values in this. There are no missing values. Unique values. What are the unique values we are having? Is there any negative value? No negative value now. Huh? Just only 0 is there, but there is no negative value. Okay. Let me try with by adding plus 0.001. Okay. So I'm going to get the lambda value as 0.2, and let me check the same thing. Okay. Dot skew. Now it has converted to 0.32. From where it has brought? From 4.72 to the original data set. The original data set is having what is the skewness value of the original data set? 4.78. Now it has brought to just 0.72. df of fair column. If you take the original fair column, dot skew. If you do the skew, 4.78 is the original skewness. And now after transformation, just have got to 0.32. So whenever you apply the Box-Cock transformation, 100% you will get the normal distribution. Automatically you will get the normal distribution, where the skewness will be between -1 to +1. It will not be exactly 0. No, sir, I want exactly 0. Then it is better to go with the root transformation. In the root transformation, you will get exactly close to the 0. More close to the 0 you can get in the root transformation. Is that clear, guys? So by using this either nth root or log For left skewed distribution, we are going to use nth power or exponential. Now, what is nth power? How to write the code for nth power? df of fair column, if you take the fair column, to the power of 1 by 2. To the power of 1 by 2 means it is nothing but square root. If the same thing you are going to take df of fair column to the power of 2, then it is whole square. Whole square means power, nth power. Whole cube, whole to the power of 4, whole to the power of 5. This all comes under power. If you write 1 by means, then it comes under root. 1 by 2 means square root, 1 by 3 means cube root, 1 by 4 means fourth root, 1 by 5 means fifth root. That is the difference. If you write like this, the code, this is called as square root, root transformation. This is called as power transformation. Right? Now you are going to apply this either nth root or log or nth power or exponential and along with the box score. These are the various things which are used for transforming the skewed data to normal data. Is that clear? Clear, guys? Any questions in the future transformations? Converting a normal skewed data to normal data. If in your original data set, if in original data set, if you find skewness minus 1, 2, plus 1. Okay, if you find the skewness is minus 1, 2, plus 1, just ignore that. Don't do any kind of transformation for that data. Just ignore. Don't apply. Don't try to more close to 0. Don't try. Waste of time. Right? Just ignore. Assume that the data is normal between minus 1 to plus 1. If the skewness value is minus 1 to plus 1, assume the data is normal and just ignore that one. If anything greater than plus 1, any skewness is greater than plus 1. If any particular column, the skewness is greater than plus 1, it is a right skewed. And for right skewed, you apply immediately either log. First you try with the log. After that, you try with the root. If the log gives the best answer, then don't apply the root. Go with the log only. Why? Because it will do in fast, comparatively fast. When compared to this one, this will be comparatively fast. Sir, how I can know whether it is fast or slow? Just by checking the time. How to check the time? Percentage, time it. Percentage, time it. If you write that one, it will tell how much time it has taken for that particular cell to calculate. Okay, it will show how much time it has taken for that particular cell to calculate. For example, this one is there. I'm calculating percentage, time it. So it is going to check, see how much time it has taken. 1.04 microseconds plus 50.6 milliseconds plus 50.6 microseconds. So total it has taken with respect to this much of time. Now let us try with the same thing for this particular cell. The same thing I'm trying for this particular cell. Now for this cell, it is 2.28 milliseconds for each time. Means total 4,000. How many records are there? 43,400 records are there. For each record to convert, it is taking 1.04 millisecond. It is taking 2.28 millisecond for each record to convert to square root of 27. 27th root it has to convert now. For each one to convert to 27th root, it is taking 2.28 milliseconds. For converting to log, it is taking 1.04 milliseconds. If the answer is same, for you both the answers are same, the skewness value in this case and in this case, everything is normal distribution. Then if answer is same, second priority will give for the time. So that is the reason when compared to root, why we have to go with the log. Log will be converted very fastly. Is that clear, guys? Now, in this case, in the box cock, what is meant by param? Param is nothing but whatever the lambda value. For which lambda value it has converted to skewed to normal. What is the lambda value? Lambda is unknown, right? This lambda. So it is saying for the lambda of 0.21 means x to the power of 0.21 minus 1 divided by 0.21 has given you the skewness to 0.32. This is the best lambda value, it seems. Box cock transformation automatically it will do. Right? Is that clear? Done? Any questions? So in this way, we are going to do the future transformation. Next one concept is called as future scaling. Next one is called as scaling. Now, this is one of the most important one. Most out of all of them, this is the most important one. Scaling. We have to scale down the data. What is meant by that and why we have to do? Right? Scaling. What is meant by scaling? Right? Now, x is equal to 1, 2, 3, 4, 5. You are having like this. Assume. What I am going to do is scaling. Scale means everything I am going to divide by 100. That is 0 0.01, 0. 0.02, 0.03, 0.04, 0.05. I'm going to divide every value with 100. This is called as scaling. Example. Okay, one of the example scaling is you are going to divide by instead of divide by 10, instead of divide by 1000, anything is called as scaling. Now, what is meant by scaling means just you are going to reduce the values. The original value data, you are just trying to reduce that one. Now, why we have to do that? What is the reason of doing the scaling? Now, what is the reason of doing the scaling means? If you apply there is a concept called as distance. Distance between 2 points. This is x1, y1. This is x2, y2. Distance between these two. How to calculate the distance? Square root of x2 minus x1 whole square plus y2 minus y1 whole square, which is called as Euclidean distance in our maths. You know how we have got this one? So just clearly observe this one, how we have got miss. So here, whatever the scatter plot we are having, in the scatter plot, this is the x1, this is the x1, and this is the y1. So this is the point. Similarly, this is x2 and this is y2. Now, can I draw a parallel line like this, one line? Now, what would be this point? x2 comma y1. Is that clear? Because x2 is, this is the point means x2, y is here, y1. Now, this is, now here it is forming a right angle triangle. This is A, B and C. Right angle triangle. For right angle triangle, we can apply the Pythagoras theorem. That is C square is equal to A square plus B square. A, what is A means the distance between these two. The distance between these two means from here to here, already y is constant. Y is not changing. Then what is changing? X is changing. So what is the x value? From x1 to x2 it is changing. So A is nothing but x1 minus x2 or x1 minus x2, anything, because whole square only now we are going to do. Either 2 minus 1 or 1 minus 2, anything is okay. Similarly, here also x2 is constant. This is y2 minus y1. So now here x2 minus x1 whole square plus y2 minus y1 whole square, which is nothing but c square. Now c is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Means this area, this line, this distance. In that way, we have got the distance value as this one, that x2 minus x1 whole square plus y2 minus y1 whole square. In the back end, Pythagoras theorem is applied, right? So, okay, now Pythagoras theorem, okay, and distance formula, okay, fine. Now, what is the use of this one means? Let us understand this. So, for example, I'm having one column. Okay, the column is called as number of bedrooms in a house. Number of bedrooms in a house. So for 1 BK, one room will be there. For 2 BK, 2 will be there. For 3 BK, 3 will be there. Okay, something 1, 2, 3 or maximum 4, something. Right? Now, square feet. Square feet. How much square feet? Either 800 square feet, 1000 square feet, 1100 square feet, 1600 square feet, something. We are having some numbers. Right? Now, if I observe the distance between these two, what is the distance between record number 1? This is the record 1. This is the record 2. What is the distance means? 1 minus 2 whole square plus 800 plus 800 minus 1000 whole square. That is square root of 1 square plus 200 square, which is equal to 1 plus 440,000. Right? Now, which is nothing but square root of 40,001. Okay, which is what? 40,001. The answer will be, which is close to 200.04, something like this. Right? Something you are going to get like this. Now, if you observe here, this second one has completely dominated the first one. Here, for the predicting the house price, I want to predict the house price. For predicting the house price, now what happens if I apply the distance concept? Some algorithms will apply the distance concept. For that particular algorithms, wherever it is applying the distance concept, what happens means wherever the magnitude is very high, this variable will suppress the other variable. Now from this, I'm going to conclude this is not important. For me, this is not important. How many rooms are there? Not important. Only SFT is important. Some houses might have 1200 SFT, but it is a 1 bedroom only. Some will have 900 SFT, but it will have 2 bedrooms also. Anything is possible. Now, what happens if I start analyzing like this? It is going to ignore the entire number of bedrooms and it will focus only on the square feet. Now, this square feet variable is dominating the other variable due to its magnitude, very high magnitude. Now, while predicting the house price, I have to give the same priority for the square feet. I want to give the same priority for the bedrooms. Both of them should be on the same scale. Then what I'm going to do, this one, I'm going to divide by 1000. Now what I'll get in terms of first one is 0.8, 1, 1.1, 1.6, something I will get like this. Now if I apply the distance concept, square root of 1.2 whole square plus 0.8 minus 1. 0.8 minus 1 whole square. Now, this is priority is there. This one also value importance is there. Both of them are having equal importance now. Now, when we have to apply this future scaling means if one of the variable dominates the other variable with its magnitude, then we are going to apply the scaling. To be more simplified, in simple words, in order to bring all the futures on the same scale, we are going to do the future scaling. In order to bring all the futures on the same scale. Why we have to bring everything on the same scale? Because everything of equal priority. Everything you want to give the equal priority. Okay. So everything you want to give the equal priority. For that, what you are going to do? Just you are going to do the scaling. You are going to apply the scaling. In the scaling, we are having two types. One is called as standardization and the second one is called as normalization. One is called as standardization, second one is called as normalization. Okay. So this concept of standardization, what is the max behind the standardization? What is the behind the normalization? When we have to apply standardization, when we have to apply normalization, these things we are going to discuss in the tomorrow's class. Because in next 5-10 minutes, we can't complete this one, right? We'll continue in the tomorrow's class. Future scaling, we'll continue in the tomorrow's class along with the future scaling, encoding and discretization. These three techniques we'll complete in the tomorrow's class. Okay. So please practice whatever we have discussed till now, and I'm going to upload the notes of complete data cleaning and data transformations. Both the things I'm going to upload. Just give me a minute.